Okay.
Warren, I just came back from the doctor's and he told me I had something and I don't understand what it is and how I caught it. He said I had type 2 diabetes. What does that mean?
You said you have type 2 diabetes?
Uh-huh.
Okay.
How can I catch that?
How can you catch that? So great question. There's numerous risk factors which can cause you to get type 2 diabetes. Some of the big ones being weight. So if you're overweight, inactivity, family history, meaning genetics, and then your age, and then your blood pressure, all possible risk factors which can lead you to get type 2 diabetes.
I don't have any of those things, so I must have caught it from someone.
This isn't a thing that you can just catch from somebody else. This is a genetic disorder or disease, or it's a problem with the amount of insulin from the beta B receptors that you're receiving. It's not like a disease that you're able to catch. It's not contagious.
Okay, so I don't even understand those words that you just said.
Okay, so do you want me to tell you what type 2 diabetes is to make you understand a little better?
Yeah, because I'm like not happy right now.
Okay, so say that you were eating too much, right? And this would cause you, this goes back to the inactivity or the diet or the overweight. This causes you to have a constant high blood glucose. There's too much sugar in your blood, okay? And this causes for your B cells that release the insulin to be constantly secreting insulin, which causes them to hypertrophy and get too big for what they're supposed to be. But beta B cells aren't really supposed to get hypertrophy, so they become fatigued. But when they are hypertrophy, there's the constant release of insulin, and the insulin sensitivity over time to kind of go back down to this normal becomes decreased. And then also you're going to see a down regulation of your insulin receptors on your beta B cells. This is all to kind of minimize the amount of insulin it's releasing, so your beta B cells are kind of going back to normal. But this happens the same time there's going to be fatigue and atrophy of your beta B cells. So that way the muscle goes from, or your beta B cells goes from big back to a normal size. Another big issue that can play into this is, say you're overweight, you're going to see an increase in adipose tissue. So this is your fatty tissue around the body. This increases an increased release of adipokines, and these also attack the insulin receptors on the beta B cells, further down regulating your receptors. And all this comes to one conclusion: you're going to have a reduced insulin sensitivity, and you're going to have reduced insulin delivery. And then your body's going to kind of not be able to store glucose as a glycogen. So your cells, when they need to eat stuff, they eat glycogen that's inside of your tissue, and insulin is what converts your blood glucose and it's the glucose in your body into the glycogen through glyconeogenesis. Okay?
There's things eating stuff in my body.
There are things eating stuff in your body.
I have fat stuff and skinny stuff that I've like gotten too fat and then gotten too skinny and now it doesn't work. I don't understand.
Exactly. I can kind of break it down some more for you if you want.
Yeah.
Okay, so when this occurs, kind of the big problem with it, or we can say the life fit associated with this, is when the reduced storage of glucose and the increased demand of glucose and the decreased gluconeogenesis causes your tissue or your cells to get starved. And this is going to cause the release of counter-regulatory hormones. This can be seen through the breakdown of protein and the breakdown of lipids. This would be proteolysis and lipolysis. And you'll also see an increase in glyconeolysis. So this kind of breaks down to have more sugar in your actual bloodstream. But this is kind of for no reason, because your tissues and your cells are kind of confused. They think there's no glucose in the blood, right? But the problem is there's no insulin converting this glucose into something the cells can actually eat. So when they're breaking down more glucose, you're thinking this is to get back to the normal amount of glucose in the blood, and then eventually there'll be gluconeogenesis and they'll have their sugar to eat. But this is never going to come because of the insulin problem. Okay. And this all results in this whole terminology is called gluconeogenesis. So that means the production of new glucagon or new glucose.
Okay, so then if have glucose, don't have glucose, if I just don't eat sugar anymore, I'll be fine.
That's not really how it works because this becomes a chronic issue. So there's going to be a chronic deprivation of insulin. So you're going to see the constant proteolysis and lipolysis, which means your sugars are always going down. And just because there is sugar doesn't mean it's actually like the sugar you put in your tea or something like that. A long-acting sugar is a protein. A medium-acting sugar is a carb. And then the short-acting sugars are what you think of as normal sugars. So sugars are kind of a general statement rather than what we use for cooking. It's kind of just a term we use for energy in the body. But let me just talk quickly a bit more about some more life threats associated when your blood sugar gets too high and this whole chronic hyperglucose levels consists, and that's going through HHS. You'll see an increase in blood viscosity as the sugars are too high. Same reason why honey is more dense than water is because of the high amount of sugar inside of honey. And when this happens, you're going to see some fluid shifting into the interstitial spaces inside of the body. And you're going to see some glucose enter the renal tubes. When glucose enter these tubes, you're going to see some water follow. You're going to see a lot of urination. You're going to see some hypovolemia. This is because when you're peeing out so much, you're going to see a reduction inside of your new production of blood, and you're going to see your liquid levels decrease. And then as you're peeing so much, you're going to see electrolyte loss. This is because you're peeing out sodium, you're peeing out chloride, you're peeing out these vital electrolytes for your body and your blood's buildup. You're going to see a proper electrolyte loss, which can lead to types of shock.
Wait, what? Okay, is that why I have to go to the bathroom all the time now?
That's why you have to go to the
And I have to
bathroom.
go thirsty all the time?
That's exactly why. Because you're peeing out so much, your body is going to want to kind of bring in more liquid.
Okay.
But the problem with, pardon?
Well, you said something about electrolytes, like, I don't even remember the words you said. So what if I just drink Gatorade then?
Gatorade's not going to do it. The problem with this is your body is not storing the glucose back into your tissue. So if you bring in all this more stuff, you can eat as much food as you want. This food, because of the lack of insulin, isn't becoming converted into glycogen. If it comes into you, you're going to pee it right out. So you can eat all you want. Your body's going to be burning the proteins and the lipids inside of your body, and then be burning these tissues for energy rather than the glycogen it should be storing up. So no matter what you eat, it's not going to get stored because there's no insulin to convert the glucose into glycogen for your cells.
But I don't need to store it. I'm just like, I'm thirsty, I'm gonna drink Gatorade, and then I'm gonna put those things that I pee out in, so that I'm good.
Same thing as I just said. You're gonna drink these in. You're gonna pee them right out. And this high glucose levels, and this you can kind of tell that you have this type of diabetes when you can smell fruitiness inside your pee or fruitiness inside of your breath. This is because your body, with your breath, you're trying to expire to lower your CO2 because glucose is causing vasoconstriction. The high glucose levels is causing vasoconstriction, which is causing you to retain carbon dioxide. So when you're breathing out, you're gonna have a higher, faster rate. And this is kind of to outdo the amount of carbon dioxide. And you're also breathing out some of that sugar, or you can smell some of that sugar. And the same thing with your pee. When you're peeing out these electrolytes, you're peeing out the sugar at the same time. And that's why you have that fruity smelling pee.
Okay, so that's why the doctor gave me those sticks I have to pee on now?
That's why he's just trying to measure how much glucose you see.
That's gross.
It is kind of gross, but it's a good way to tell how you are progressing in your type 2 diabetes, because there's several types. Type 2 diabetes doesn't always mean you need insulin. In the beginning stages, you can be pre-diabetic. Kind of early stages, you can be just non-insulin dependent. This can be you'll be taking metformin and other medications to kind of supplement the amount of insulin reduction that you're finding, because like in type 1 diabetes, that means there's absolutely no insulin. So the only way that you're able to get all your energy is through the lipolysis and protein lysis I was talking about. But in type 2 diabetes, there's still a little insulin. Remember, I was saying that it's becoming desensitized. It's not becoming absent. So there's going to be a little bit of glyconeogenesis, a little bit of glyconeogenesis. Your cells they're going to be hungry. They're not going to be starved. And that's why this scary thing called acidosis isn't going to occur in your type of diabetes.
Okay, so if I just eat better and exercise, then fix.
Eating better and exercising are good ways for the beginning stages of type 2 diabetes. These are ways to kind of control the epic highs and lows of your diet, so your body is not at any time having an excess amount and being in a deficit of insulin. Because the way they use insulin in actual diabetes is like you eat a meal, you get some insulin. That way that you kind of convert the glucose into glycogen, and your cells can eat that. And then when it gets even more serious, you get that after your meals, and in the beginning of the day, you get some long-acting insulin, and that kind of chronically raises your insulin levels. You have any more questions?
No,
okay.
Thank you.
You're
it helped a lot.
You're welcome. Okay. Bye.